In this video, I'm going to talk to you about the volume of pyramids and cones. Let's just think about what a pyramid is first of all. So a pyramid is any kind of polygon as a base. So for example, it could be a triangular base and it meets the top with an apex. A cone, a very similar shape, only the base is circular and therefore, I don't know, like a hat or something like that. You've seen the cone hats before, or cones that you get on the road. Again, it's an apex at the top. Now, the kind of measurements that we get given when we have to work out questions where we're trying to work the volume out of these shapes is we're usually given the perpendicular height with the base from the apex right down to the middle of the shape. Okay, now it's very difficult in each shape to be able to draw that, certainly when I've got a line here. So I might often draw the height outside of the shape. Within this one, I can draw it inside, so it goes right down to the middle of the shape, and obviously it's perpendicular. That means it sits at right angles to the base. Obviously we'd have a radius in this case, but that would be the height. We sometimes get oblique pyramids or oblique cones, and oblique means it doesn't sit perpendicular to the ground, so it slants. I'm not the best artist, so I'll struggle to draw something that's oblique, but that's not bad for myself. But what we're really keen to know is what is the perpendicular height from if that apex was perpendicular to the ground. So we still go from the apex, but it's the perpendicular height, not the slant height. So I'm talking that is sitting at right angles. Now, all of these shapes have the same formula to work its volume out. The volume is 1/3 times its area times its height. A being the base area of that shape. So for this one, the base area is a triangle. So we would use 1/3 times a half base times height of that triangle times the height of the pyramid. This is a circle. So for the volume of this shape, I'm going to do 1/3 times pi r squared times the height of the cone. Similarly, this one's a circle as well, so the base area is still pi r squared, but in this case I won't be using the slant height, I'll be using the perpendicular height. So let's do an example. Let's do an example of one of these. Okay, so as you can see, I've just drawn up a square-based pyramid. So because I'm dealing with a square, the base area is length times width, or s squared if it's just the side length, or a rectangular-based pyramid, I'm my mistake, because I'm dealing with 1.2 and 1.4 here. So let's have a look. The volume of this shape, I need to work out the area of the base, which is 1.2 multiplied by 1.4, and then I need to multiply it by height. Well, let's say the height is 10 meters. I'm going to multiply it by 10. Working all that out on the calculator, I get 1.2 times the 1.4 multiplied by the 10, and then I'm going to divide the whole answer by 3. I get 5.6 meters cubed because I'm dealing with volume. Let's have a look at a cylinder. Not a cylinder, a cone. Let's do a circle with a apex. Let's go with a height of 10 again. Just shake my pen, it's running out of it. 10 meters, and let's go with a radius of 2 meters. So its volume, and I'll just clear this space. Okay, so I've cleared this space now. What I'm going to do is fill in the numbers. So I'm going 1/3. The area is pi r squared, so I'm going to multiply by pi r squared. And then I'm going to multiply by the height, in this case, which is 10. So let's sub the values in. 1/3 of pi times 2 squared multiplied by 10. Now I'm not going to use the calculator in this case. I'm going to do an exact value. That means just writing it in terms of pi. So 2 squared is 4. So I've got 4 times 10 is 40 divided by the 3 multiplied by pi. 40 over 3 can't be cancelled down, so that is as far as it's going to go. And that is how you work out the volume of any pyramid or any cone using this formula here, where A is the area of the base and H is the perpendicular height up to the apex.